Now we will see the post-processing of ANSYS Fluent. So the solution has been done. Now you want to see the results. So here you have the results option. This is Fluent's own post-processor. You have also here ANSYS post-processor. So we will learn both of them. So if you go to Fluent, go to graphics and animation. In graphics you have lots of options. First is the contours. If you go to the contour and setup, you will see the variables. First of all, the pressure, density, velocity. Let's say the velocity, and here you have the other option for velocity, what you want to see, velocity, magnitude, x velocity, y velocity, stream function, everything. Let's say we select velocity magnitude. In 2D you don't need to select any surface, then display. Now you can see the velocity magnitude. Here you have the cylinder and fluid is flowing over the cylinder, so the velocity is increasing, but just beside the downstream you have a low velocity because no fluid is here. So this is a laminar flow and you can see the flow field. If you select x velocity and display, it will show you the x velocity. If you select y velocity and display, it will show you the y velocity. If you want to see the stream function, you can see the stream function. Now this is a contour, let's say the velocity magnitude, and the color resolution is quite smooth because of this level. Right now it's 100%. If you change to 20, you can see the difference of the contour. You can see discrete contour lines, and here you have the field option. So if you uncheck this field option, you will only see the lines. So if you want to see only the contour lines, you can see that. If you want to see the contour filled with color, you can also see that. If you want to smooth this color, you can change it to the level 100%. One thing you need to understand that this level is just the color level. It will not affect your results or anything. It's just the presentation option, how you want to present. Another thing is this color bar. As you can see, if we increase the level, these values are very congested. So how we can solve this problem? Very simple. If you go here, display, and you have the color map, so go here. Right now in the color map, these labels show all is selected. So if you uncheck this and apply, then you can see the values are much further. So if you want to change this, skip 20 to 10. Now it's more congested. If you want to 10 to 15, you can see this. So this is representing the velocity magnitude. If you want the type of representation, right now it's exponential. You can change it to general, apply, it will show you the general value. If you want to see float, it will show you the floating option. You can change the precision also, let's say 5 times, then you can see. You can also change the color option. If you select this, it will change your color. You can stick with single color, or you can change it to grayscale. You can change it to rainbow color, whatever you want. It depends on how you are presenting your calculations. If you don't want this color bar here, if you want a color bar at the bottom, you can also change that. Go to display, go to option, you have the display option here. Here you have the layout, what type of thing you want to see in the display option. Here is the title bar is this contour of the velocity magnitude. This is the title bar. If you uncheck this, your title bar will not show in the graphics window. The color map, here in the color map alignment right now it's left. If you want to change it to bottom and apply, you can see this color map, but the values are very congested. So what will we do? We will go to display, color map, we will change it to skip option, we will do it 20, apply. Now you can see much better. So this is the velocity contours. You can change it to pressure. You can also see the pressure. If you want to see vorticity magnitude, you can see the vortices around the cylinder. Now, how you save this picture? So if you go here, save picture, then you will see this picture saving option. Here you have the format, what type of format you want. If you want JPG, you can save it. If you want PNG, if you want PostScript, you can choose one of these options. Right now we want JPG. So here, and coloring. If you want the picture, color picture, you can select the color. If you want grayscale, you can select grayscale, or if you want monochrome, you can also select that. So we want color. Here you have the resolution of your picture and the option white background or black background and the orientation. So we want white background and save. So it will ask you where you want to save. Let's say we want to save it in the desktop. So name it file cylinder flow and save it. So if you go to desktop and select this, then you will see the pictures. Right now the picture is little bit bigger than the window. So what we can do, we can change this resolution, or we can zoom out a little bit and then save it again, the same name. Then you can see the total picture. So these are the way you can save your contour pictures or any pictures, any plots. Now you have another option for the vectors. These vectors will give you the vector field. Right now here you have the vector of what velocity, colored by, you can change the color. Let's say we want to see the vector field based on vector magnitude and display. So here you can see the vector field. If you want to increase the length of the vector, you can increase the scale, and you can see the vector fields here. If you want to skip one or two, you will see the changes of the vectors. So you can play with these options and you can get a good pictures of your results of your solutions. Here you have path line. So this path line is how a fluid particle will travel along the flow stream. So here you have the options: oil flow, reverse flow, nodal value, auto range, lots of parameters. So it's better to stick with nodal values and relative path lines. That's the best options. If you select oil flow and reverse flow, it will take a lot of time to get the picture. And colored by, you can color by your velocity magnitude or your vorticity magnitude, whatever you want. Here the important thing is the step. Start with very small number, otherwise your desktop will freeze. And select the surface. We have a 2D, so interior surface body, now display. And it will take some time and it will show you the path line. Right now the path line is really congested. We can see the path line really clearly. If you zoom, you can see that. So you can do it, you can skip these things and you can see a little bit clear pictures here. Now this thing is not clear, so we can reduce this skip option. We can increase this, we can increase this a little bit. Now you can see more clearly the recirculation zone at the downstream of our cylinder. If you reduce this more, you can see more clearly. If you want to save this, you can save it in the desktop. And it will save your path line. You can see here the path line flow over a cylinder. So these are the options in the path line, how you see the flow field around the cylinder or your desired object. You have also particle track. You can track the particle in your domain, how it flows and where it goes. So it's a lengthy process. So right now in this laminar flow problem, we don't have any particle track option. In future tutorial, we will see the particle track. Now we will see how to plot a result. Here right now you have the vorticity contour. If you go to result and go to contour, if you want to plot the velocity magnitude, right now this is the velocity magnitude contour. We want to plot the velocity distribution at the downstream of this cylinder. So if you go to the geometry, and you can see our origin is at the center. So if we want to plot at the downstream location, we need to draw lines along the downstream, and then we will plot along that line. So before do that, you have to be very careful about your geometry and the dimension of your geometry. Right now the center of our origin is at the center of our cylinder, and the diameter of the cylinder is 5 inch, as you can see here. Your maximum upstream length is 50 inch and the width is 20 inch. So if this is the center of the origin, then the coordinate is 0 0 here, and at this point thing will be 0 minus 20, and this point will be 0 plus 20. So if you want d distance from the cylinder, then at this point the coordinate will be 5 plus 20. Here will be plus 5 minus 20. So if you go here in the contour option, you will have a new surface. So select here. It will ask you what you want to create. We want to create a line, and at that line we will draw our variables. So select line. Here it will ask you the 2 coordinate for a line, because we all know that to draw a line we need 2 coordinate point. One point is here and another point is here. So we don't know this point but can provide these points. Right now it's in meter, so you will get confused how much we need. You can convert it from inch to meter, or you can change it. Go to here, general, and go to unit. In the length option you can change it to meter to inch. Close it. Go to contour, new surface, line. Now you can see the endpoints. So let's draw a line at the middle. So this point will be 0 minus 20 and this point will be 0 plus 20. So let's try this. So our x0 will be 0, y0 minus 20. Our x1 will be 0, y plus 20, and we will name it line 1. Okay, create. So if you want to see the line, go to this graphics and animation mesh setup, and right now these things are selected. Display, it will show you this. Uncheck the surface interior, it will show you just the outline. Now you select this line 1 and display. Now you can see very closely this line has been created. So we don't want this line, we want a line at d distance apart from this line. So what variable we will change? We will change our x variable, and that is towards positive x direction. So we will do it 5. This would be line 2. Create. Now your line 2 has been created, and if you select this and display, then you can see your line 2 has been created. If you want 2 more line at d distance apart, so select 10, and this would be line 3. Create. Line 3 is here, and if you want 1 more line here, 15, create. You can see here. So you have 4 lines. So we want to see the velocity at line 2, line 3 and line 4. So you have created the line. Right now you want to plot the variable. So go to plot. Here you have the XY option. You have also can plot the histogram. You can plot the profiles, which is not available for 2D. So in XY plot, go to setup, and it will ask you the Y function and the X function. So right now this line is a vertical line. So what we can do, we can keep it as it is, and we can change our variable. We want to see the velocity magnitude, and what line? Line 2. So plot, it will show you a single line. So what's wrong with this? The problem is, if you closely these lines are vertical line, so that the direction vector is in y direction, but here our direction vector is right now is x direction. That's why it plots like this. So the direction vector means your distance vector is changing along x direction, but our line is at the y direction. So what we have to do, we have to change this direction vector, make y equals to 1, x equals to 0, and plot. Now you can see the velocity distribution along line 2 here. So if you go to contour, and if you see here, the velocity, here you can see a high velocity, the velocity is reducing. Here the velocity is very low and the velocity again increases. The same thing happens in the plot. You can see here the very high velocity and it reduces here. You can modify these directions also. If you change this position to y-axis, it will ask you, it will reverse the direction. Plot. Now you can see this is along the airstream line, but we will stick with this. So if you select line 3 and plot, it will show you the plot at line 3. If you select line 4, it will show you the plot at line 4. And if you select line 1, it will also give you this, which is not clear. So these are the points. So let's say you don't want a point, you want lines. How you can do that? You go to curves, and here the pattern, you can select the line pattern, apply, and then plot. You can see the plot. You can also change the color. If you want to change the color and apply, it will change the color also. So you can play with a lot of things. But let's say if you have two curves and one is line, another is plot dot, and you want to make it also the line, change the curve number here. This is number 1. So change it to another curve type and apply and plot. Now you can see you can change it to different colors. You can save this plot. You can save this plot as a picture if you want. See the desktop line plot. And if you go here, you can see this curve, or you can go here in the plot option and you can write this file. So if you select this write, this plot option will change to write option. Write the file name, let's say first plot, and it will save it as a xy file. So go here, xy file. You can open this xy file notepad or Microsoft Excel. So if you can see here, for line 2 you have this coordinate and the velocity. For line 3 you have also this. So you can copy this and you can paste to Microsoft Excel, or you can easily open this directly from Microsoft Excel. So this is how we can plot our variables, and we can post process it with different types of plotting options. And here you have the report option, which is also important. If you want to see the force, you can go here and set up what type of force you want to see. If you want to see force, you can select the force and select the wall and print. It will print in the printing console. You can see the total force, how many force is acting on your cylinder. If you want to see the momentum, you can also see the momentum. If you want to see the center of pressure, you can also see the center of pressure where it's acting at the center. This amount is very tiny. So you can play with all of this. You can write these things in a notepad for your report. You can also integrate lot of stuffs. When we will do thermal problem, we will see how to calculate Nusselt number, how to calculate surface heat transfer coefficient. Then we will use this surface integral, area weighted average integral, and other stuffs. From next tutorial, we will see specific problem, and we will start from the geometry development to post processing. Thank you.